And the last thing that we're going to talk about with regards to carboxylic acids and their acidity is how we can modify the structure of the carboxylic acid to change its acidity. As a rule, the more you put electronegative atoms on a carboxylic acid, the more acidic it becomes. The reason for this, well, actually, let me draw some out and then we'll talk about the reason for this. So let's compare. We're going to just draw a whole bunch of 4-carbon carboxylic acids. We'll draw 4-carbon carboxylic acids, and then we'll come back and put some halogens on them. So for the first one, let's put 2 chlorines on carbon number 2. For the second one, let's put 1 chlorine on carbon number 3. For the third one, we'll put 1 chlorine on carbon number 2. And for the last one, no chlorines at all. So the more electronegative atoms you have on a carboxylic acid, the more acidic it is. To help us understand that, what we need to do is think about when a carboxylic acid is being an acid, what is it turning into? What is it becoming? When a carboxylic acid is an acid, that means that it is getting rid of its hydrogen. It's becoming an anion, negatively charged. And the more stable these anions are, the stronger the carboxylic acid was. So anything that is on these structures that can help stabilize that negative charge is overall good in terms of increasing the acidity of the molecule. Electronegative atoms, like chlorines, like all halogens, are great at stabilizing negative charges because they drag the negative charge towards them because they're electronegative, and they help delocalize that negative charge. So when you have no negative charge no halogen at all, like this little guy out here, this is going to be the least stable of all of the carboxylic acids because it doesn't have anything helping it to stabilize. If you have halogens that are close, like this one and this one, where the halogens are very close to the carboxylic acid, their proximity, it has a more significant effect than halogens that are further away. So the closer the halogen is to the carboxylic acid group, the better it is. So this one right here, where the chlorine is kind of far away, this is, I'm gonna call least stable number 4. This guy is number 3 because the halogen is kind of far away. So now we have it narrowed down to 2 carboxylic acids. They have halogens on the same carbon in the same spot, nice and close. And as you can probably guess, if you have 2 halogens on a carboxylic acid, they're both working together to stabilize. And just 1 halogen, not quite as stable.